We're surrounded by data every single day, but do we really get what it is? Well, that's what we're going to break down today. We're talking about the fundamental types of data. And trust me, this is the essential first step if you want to make any sense of the world through information. So let's start with a little thought experiment. Is a 5-star review the same kind of number as $5? I mean, they both use the number 5, right? But do they really mean the same thing? Could you do the same kind of math with them? This is the core idea we're going to be unpacking. But before we can even touch that question, we got to back up a step. We need to build a solid foundation. So let's start with the most basic question of all. What is data, really? At its heart, data is just a collection of raw, unprocessed facts. Things like exam scores, the ages of customers, or the prices of different products. On their own, they're really just numbers sitting on a page, waiting for some context to make them useful. And that's the magic trick right there. It's only when we start to process and analyze this raw data that it transforms into something incredibly powerful: information. This is how we uncover patterns, how we understand trends, and how we make much, much smarter decisions. Think of it this way. Data is the raw ingredient, information is the delicious finished meal. Okay, so how do we start cooking with this raw data? Well, the first and most important way to sort it all out is to split it into 2 giant groups: things we can count or measure, and things we can just put into categories. And that big split leads us to our 2 main types. On one side, you've got quantitative data. This is everything to do with numbers. It answers how much or how many. We're talking about your age, your height, your income. On the other side, we have qualitative data, which is all descriptive, non-numerical stuff. It's all about what type of thing it is, like your gender, eye color, or blood group. I mean, you can't really do math with eye colors, can you? All right, so let's zoom in a little bit on that quantitative, numbery side of things. Because it turns out, not all numbers are created equal. There's another really important split we need to understand here, and it's the difference between data we count and data we measure. First up, we have what's called discrete data. This is basically anything you can count in whole numbers. Think about the number of students in a classroom or the number of cars in a parking lot. The key thing to remember is you can't have a fraction of one of these items. And this really hits the nail on the head. You cannot have 2.5 students. It's just impossible, right? Discrete data always has these clear, separate gaps between the possible values. So if discrete data is things you count, the other side of that coin is continuous data. This is anything you can measure, and it can take on any value within a given range, decimals and all. Think about height. You could be 165 centimeters tall, or 165.5, or even 165.51 centimeters. The possibilities are pretty much infinite. Same goes for things like weight or temperature. Okay, so we've covered the really big splits. Now, let's layer on a more sophisticated framework that statisticians use all the time. You can think of these as the 4 official levels of measurement, kind of like the rules of the game for handling data properly. And to help you remember these, there's a great little acronym, NOIR, or NOIR. It stands for Nominal, Ordinal, Interval, and Ratio. The best way to think about it is like a ladder. Each step you climb up adds more properties and lets you do more powerful analysis. So let's start at the bottom of the ladder with level 1, nominal. This is the most basic level you can get. It's just about names or labels. Think of categories like gender or the names of countries. There's no natural order here at all. You can't say male is greater than female or that Canada somehow comes before Brazil in any meaningful sense. They're just labels. Climbing up one step, we get to ordinal data. This level introduces order. With ordinal data, the categories have a meaningful rank. Take customer satisfaction. High is obviously better than medium, and medium is better than low. But, and here's the catch, we don't know how much better. The gap between low and medium isn't necessarily the same size as the gap between medium and high. All right, moving up to level 3, we have interval data. And this is where things start to feel a lot more mathematical. Like ordinal data, it has an order, but now the differences between the values are equal and meaningful. The classic example is temperature in Celsius. The difference between 10 and 20 degrees is exactly the same as the difference between 30 and 40 degrees. But, and this is absolutely crucial, there's no true zero. 0 degrees Celsius doesn't mean there's an absence of temperature. It's just another point on the scale. And finally, we've reached the top of the ladder, ratio data. This is the most informative level of them all. It has everything that interval data does, order and equal intervals, plus a true absolute zero. And a true zero means a complete absence of whatever you're measuring. Zero income means you have no money. And because of that true zero, we can now make meaningful ratios. Someone earning $100,000 really does earn twice as much as someone earning $50,000. So wow, we've walked through a whole bunch of classifications: nominal, ordinal, quantitative, qualitative, but what's the big deal? Why does any of this actually matter in the real world? Let's bring it all home. Let's do a super quick rundown. Nominal is just categories. Ordinal adds order. Interval adds equal spacing, and ratio at the top adds a true zero. So this brings us all the way back to our original question. A 5-star review is ordinal data. We know 5 is better than 4, but not by how much. But $5 is ratio data. It has a true zero. They are fundamentally different kinds of numbers. And here's the bottom line. The reason this is all so vital is because the type of data you have literally dictates everything that comes next. It tells you what kind of charts you're allowed to make, which statistical tests are actually valid, and ultimately what conclusions you can legitimately draw from your results. If you use the wrong method for your data type, you're going to get meaningless or just plain wrong answers. So I'll leave you with this challenge. The next time you see a statistic, a chart, or some claim based on data, just pause for a second and ask yourself, what type of data am I actually looking at, and what can it truly tell me? Answering that simple question is the first giant step toward becoming a more critical and informed thinker.